and welcome to Tuesday's edition of Cracking the Cryptic. And I'm actually going to start today by looking at yesterday's puzzle again. This featured in the third movie because of how long this took me to solve. It's by Sudoku Explorer, and many of you commented to say that you'd found a really elegant way to break in that was a bit less complicated than the way I found. And one of those ways in particular tickled me, so I thought I'd share it with you now. I was very pleased, by the way, to note that those people who did find an easy break-in still found the puzzle monstrously difficult, because that would have been thoroughly depressing if not. But let's go into this and see how we could have solved it without how we could have broken into the puzzle without Phistomefel. In other words, how would we get those two squares had to be ones without using Phistomefel or any jiggery-pokery around set equivalence theory? Well, watch this. If we look at those squares in box 1, you can see that because of our little secret, which is that all of the cells in box 1 must add up to 45 because they'll contain the digits 1 to 9, and we see 22 there, so we know that those cells must add up to 23 to make the box add up to the right number. But what some people noted was that because this arrow here, this domino, is adding up to this total, we can actually shortcut that and say that those cells there also add up to 23. Now if we do the same thing down here in a slightly different way but very similarly, we know these squares must add to 21. Because of this arrow's geometry, we therefore know those cells add to 21. And now, where do the purple squares go in the cross? It's really lovely because the purple squares, because they can't go anywhere in these cells, and this is a 9-cell cage, they must go in those squares. So now we have 23 for the purple, 21 for the blue. We know the whole row adds up to 45, so this square is a 1. And obviously if we just do the logic in reverse up here, we'd get exactly the same thing and be able to prove that's a 1 as well. I thought that was lovely, so really well done if you spotted that. You definitely found an easier way to break into the puzzle than I did. Now, what are we doing today? Well, that is a good question. I don't know. I have an email here from Mark called Do Not Open, which I'm allowed to open, presumably now, when I've launched the puzzle. So I'm guessing this is going to be another of these puzzles that's absolutely impossible. So let me launch the puzzle. I have to go to a new tab. I've got the URL pasted in there, so I'm going to hit the return key now. And yeah, okay, well that's nothing surprising to me there. It looks like it's some sort of killer Sudoku. I don't even know who this is by the way, so I'm going to hoping that the email will reveal all. I can see I've got no digits. Right, okay, let's see. What do we have to do? So hang on, I'm going to open the email and I'm going to see that this puzzle is by Quinlux. Okay, well I like Quinlux's puzzle. It's called Build Your Own Killer. And I think I've done, was it Build Your Own Little Killer I did the other day? Well, this should be brilliant. I like Quinlux's puzzles. So, the rules are as follows. Normal Sudoku rules apply. Good. Additionally, there are some empty cages in the grid. I've seen those, yes. In these cages, digits do not repeat. And somewhere within them is their cage total. No, there isn't. I.e. their sum, which is always 2 digits next to each other, read left to right or up then down as a 2-digit number. It is up to the solver to determine what each cage's sum is. Consecutive cages that share an edge, cannot sum to 63. What? So, each cage contains its sum represented as a 2-digit number, and the digits, oh I see, right, okay, good lord, that's incredible. So we've got to, so this cage, for example, whatever this cage adds up to, somewhere within the cage will be that total. So if this cage added up to 23, it would be it could have a 2 there and a 3 there. or a 2 there and a 3 there, but it must have 23 written in it somewhere. Let's find a down one, this one. So in this cage, if this cage added up to 41, there would have to be either a 4 and then a 1 going vertically, so something like that, or a 4 and a 1 going horizontally, something like that. I think that's what it's saying. That's quite amazing. Well, no, let me temper that slightly. That is quite amazing that it's solvable, given that. Because I can imagine you could build a killer Sudoku that had that property and then take the numbers out of it and present it to muggins like me for solving. But I'm quite surprised that this has a logical path, but it obviously will do, unless Mark is being incredibly irritating, which I wouldn't put beyond him. Anyway, we're going to have a go at this in a minute. Before we do have a look at what's going on Patreon as always. There is loads of good stuff, and of course, in about a week's time, we are releasing Demono's Secret, or sequel, I should say, to what puzzle? This puzzle. The sequel to this puzzle. Everything is Roggen. So that ought to be a lot of fun for many of you. Let's get rid of that. Get back here. The way to play this is to click the link under the video. Now I get to play. Let's get cracking. Now, how do we do this? We've got a 9-cell cage there. Right, okay, let's start here then. Because I know in fact, we've already talked about this in the video, a 9-cell cage must add up to 45. So in this cage, there must be a 45 somewhere. Now, unfortunately, I'm not exactly sure where that 45 goes. I think it could go in a lot of different places. Actually, it could go there, 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 or there. Right, okay. That's not where we start. Right, okay, where else should we start? I'm looking at the rules to see if there's any help here. Consecutive cages, i.e. cages that share an edge, cannot sum to 63. So presumably that's telling us that any cage that touches the 45 cage cannot be an 18 cage. I wasn't really expecting it to be an 18 cage, if I'm completely honest. So all of those cages can't add up to 18. Is that telling us something? No, I'm not as far as I can see. No, I mean, in fact, this is really difficult, I'm suddenly realising. I'm not exactly sure what on earth we do. Is there something funny about 3-cell cages? Well, right, okay. Well, a 3-cell cage can't add up to 20-something. I can see that. And the reason is, although you can make 3 cells add up to 20-something, you can't if one of the digits is a 2. So if we try and put a 2 here, for example, because we want this to add up to 21, we've got a problem. Because these 2 squares will have to add up to at least 18. Well, 19, really, because we can't have them adding up to 20, because I can't do that. So that's not going to work. So there must be a 1 in a 3-cell cage. Okay, well that's something, isn't it? There's a 1 in here. And the 1 can't go at the bottom of the cage because the 1 has to be in the total, if you see what I mean. So it's in this cage, it's going to be a vertical total that's going to be a sort of teenage number. That one's a 3-cell cage. Come on, 3-cell cages, come to rescue. Another 3-cell cage. I suppose this one can't have a 1 there, because it wouldn't work. If the 1 is the tens digit, it won't work. That one can't be there. Is that all the 3-cell cages? Oh, look. Well, these at least allow me to do a bit of Sudoku. The 1 in the 9-cell cage is at the top of the grid. Okay, that's not done anything, has it? No. 4-cell cages? Now, can a 4-cell cage add up to 20 something. Oh, that's really weird. No, it can't. Okay. Okay, no, it can't, because something I'm just realizing about these cages are, let's look at this. If this is 24, just for the sake of exposition, if this is 24, this digit here is, we can almost ignore this in terms of working out what's possible. The units digit, which is part of the total, sort of, it counts and then it's discounted, because whatever this digit was, it's not affecting what the other three cells have to be. We can, if you see what I mean, if we're saying the total is 24, 25, 26, 27, 28 or 29, this digit is not affecting these three digits. These three digits still have to reach a total of 20. Right. And therefore, if this is a 2, these two digits always have to add up to 18, which is impossible because you can't put double 9 in the cage. So that does mean there's a 1 in here. Sorry, I'm just trying to think about that, because the fact that the units digit is a bit irrelevant. It makes me want to do maths in a way, because we can represent any cage total as 10x plus y, where x is the tens digit. And then we're saying that in the cage, so we're saying 10x plus y is equal to x plus y, because x and y both appear in the cage, plus a sequence of other digits. Now what that means, if we can cancel out y from both sides of the equation, we can deduct x from 10x and get 9x. So we've got 9x is equal to the sequence of the other digits. And that means that in every cage, the digits that are not part of the sum have to sum to something that's divisible by 9. Now, many of you, I'm sure, will have figured that out instantly, but I didn't. And I'm just wondering if that means anything useful. Yes, it does. It means something very useful for the 3-cell cages. Because, yes, it's lovely. Okay, let's look at the 3-cell cages. So wherever you put the total, let's make the total 14 here. If this is 14, the other digit has to be divisible by 9. So it has to be 9. That's the only way that's going to work. We can think of it, if you like, that the 1 and the 9 here have to add up to the tens digit. So here we know that effectively we can represent the number 14 as 10 plus 4. And given the 1 is always got to be in the cage, the other cell has to be 9. 1 plus 9 obviously equals 10. So, okay, so there is definitely a 9 in here. That's not going to be true. Well, it's not true for a 4-cell cage, but it is true to say in a 4-cell cage where the total is a teenage number, there are 2 cells in this cage that have to add up to 9. And yeah, that's not helpful. 9 is in one of those. 9 can't be in the middle of the cage, because if it's in the middle of the cage, you can never make the 10 number appear in a consecutive domino. So the 9 is not there. The 9 is in here in the 45 cage. The 9 is in one of 2 places in this 3-cell cage. It can't be in the middle. And we are finding some logic here that is very, very cool. Now, what do we do next? We can... if there's another 4-cell cage. That one. That's a 4-cell cage, so that must have a 1 in it. and the 1 can't go there, because then I couldn't make either a vertical total or a horizontal total from here. Good grief. I mean, I've really done some interesting stuff. I've got absolutely nothing from this. I've got another big cage here. This is a 7-cell cage. So in a 7-cell cage, what do we know? We know that there's going to be... We know the digits that are not in the total. So let's imagine that's the total. We're saying that 5 cells in the rest of it have to add up to a multiple of 5. So if this was 40 something, if this was 41, these squares would have to add up to 4 times 9, which is 36, which is impossible. You can't make 5 cells add up to 36 if they're all different numbers. The most you can get to is 35. So this cage is not a 40 number. Is it a 30 number? Let's just try 31 to start with. Now we're saying that those 5 cells have to add up to 3 times 9, which is 27, and I do not see why that is in any way restricted. It's more likely to be restricted with 20 something, because you're not going to be able to use a 2 in the total. Yeah, actually, let's look at that. So if this was 21, these cells would have to add up to 18, 2 times 9, without using 2. I mean, it's obvious it can't work if we put 1 here. But if we put 4 here, what's the minimum we could make those add up to? In fact, I need the 4 as well, don't I? Let's try 8. So 1, 3, 4, 1, 3, 4, 5. 1, 3, 4, 5 and 6 is 19, isn't it? I know that. I don't even know why I'm adding it up. I know that. 1, 3, 4, 5 and 6 is 19. 19 is bigger than 18. There is a knowledge bomb from Cracking the Cryptic. So 2 is impossible. That is impossible. So this cage is a 30-something total. And that is absolutely useless. I don't believe it. I don't really know what I expected, but I know this is a 30 total. Or 30-something total. Oh dear. What about the 5-cell cage? So in a 5-cell cage, you definitely can't have a 30-something total, because then the other 3 squares would have to add up to 27, and you can't make 27 from 3 cells. The most you could get to is 24. So 20-something means the other 3 cells add to 18, which is very possible. If this was a teenage number, the other 3 cells have to add up to 9. Ah, there you go. Right, that's interesting. Now, if this is a teenage number, let's just pick one. It doesn't matter, obviously, what the units digit is. It's not going to affect any of the logic. Let's say this is 17. What do these 3 squares have to add up to? Well, they have to add up to 9. But if they add up to 9, without using a 1, they must be 2, 3, and 4. So if a 5-cell cage is a teenage number, it must contain 1, 2, 3, and 4. So are there any of these 5-cell cages that can't contain a 1 now? Or that must contain a 1? No, although if they must contain a 1, that still doesn't mean they necessarily have to add up to a teenage number. Oh, bother. Let me just think about that again. Did we miss something there? It's either, if it's teenage, it's 1, 2, 3, 4, X. Oh, I see. So you've always got a 2 in a 5-cell cage. Oh, that's strange. Right, and the reason you've always got a 2 in it is it either sums up to 20 something or it sums up to 10 something, but that in order to do that it needs to have a 1, 2, 3, 4 in a cage. So there is always 2 in a 5-cell cage, but not necessarily a 1. Ah, now I can place a digit. I see. Right, let us have a look at the top of the grid where there happen to be 3 5-cell cages. So we know there's a 2 in that one, there's a 2 in that one. That's how many 2s are there going to be in this puzzle in row 1 and row 2 altogether? Not a trick question. There's going to be exactly 1 2 in row 1, there's going to be exactly 1 2 in row 2. So these cells must contain those 2 2s. But there's a 2 definitely in that 5-cell cage, and it can't therefore go in any of those squares, so that square is a 2. And we have a digit. And we have... what do we have? Actually, we have a 2 in a very interesting place, because this cannot be part of the total. It's too far down the cage. So this cage does add up to a teenage number, so must contain a 1. That 1 is not in those 2 positions because there's a 1 pencil marked into here, which means there's a 1 in one of those 2 positions, and that gets me a 1 here. I don't believe it. That is absolutely beautiful. Now, no. Now, well, I was about to say... well, now the 1 is locked into row 7 and row 8 in boxes 8 and 9, so there must be a 1 in one of those 3 squares. Not that one. Oh, yeah. Okay, so this is not a 1. And if this is, because of this pattern, this not being a 1, places the 1 here. Now this can't be the 9, because we know we need 1 plus 9 equals 10 in the box. That's a 9. That's a 9 by Sudoku. This is going quite well all of a sudden. This is a 1 by Sudoku. This can't... again, the 9 has to be shielded from the total, which is going to be these 2 digits. In fact, probably what I should do, is to colour in the totals. So that's a total. That's now a total. I use different colour, shall I? That's a total. Look at this one. We can't put the 1 above the 9, or it would imply that the total is 19. And there won't be a way of doing that without putting a 9 here as well. So this square's a 1, which means these are the 2 coloured squares. That fixes that this is a 1, which means these are the 2 coloured squares in this one. This one means I get the 1 up here, look. So now these 2 squares are the sum in box 2. This is not a 1. Oh, 1 is of course not the sum for the 45 cage, so we don't know about that one yet. We've got... well, we've got some amazing progress there. Now, can we keep it going? This cage is interesting now all of a sudden because there's a 1 here. Now that means we know there was a 2 in here, but we now know that that 2 is part of the total for this cage, because the only other thing it could add up to is a teenage number, and that would require... but the only place 1 can go is here, where it can't be part of a 2-digit domino to make the sum. So there must be a 2 in one of those 3 squares, because it can't be here, and it can't be here. Now, can we do anything with that? Don't know. This one... well, no, this one's trickier, actually. Well, no, it's not. Yeah, well, it is a little bit. This one has to have a 2 in it, so that 2 must be in one of those 3 squares. But we don't know whether this sums to a teenage number or a 20-something number. So we don't know about where the... we don't know, for example, that this is not a 2, do we? 2 here. Right, now I can fill in more things in this dogleg cage because this adds to a teenage number. That means those 3 squares have got to add up to 9, and they have to be 2, 3 and 4. So there's a 3, 4 pair in this box. And now look at the 9 cell cage, and our square 2, 3 and 4 go in the cage. They don't go in those squares because these squares obviously see those squares. They don't go in that square because that square sees the 2, 3, 4 above it. So the only place 2, 3, 4 can go is those cells. And that's... don't know what that means. Do we know what that means? Yes, we do. This cage adds to 45, so the 4 in one of those 3 positions has to be part of a cage total. I've just seen how I can do it. I was about to say it and I've broken the puzzle. I haven't broken the puzzle. This can't be a 4 because that would require this to be a 5. This can't be a 4 because there's nowhere for the 5 to go. This can be a 4. That's a 4. That's a 5. Therefore, this becomes a 2, 3 pair now. The 5's got to go somewhere in box 3 of the grid. This 5's ruling it out of the same cage, so the 5 goes here. 5 goes in one of those squares. 2, 3, 2, 3. There's a 2 and a 3 down on the right hand side of box 9. And this square can basically be anything apart from 1, 2, 3 and 4. And this square, do we know what this square is? No, I think that can be anything apart from what it sees in its cage already. Yes, here we go. This one has to have a 2 in it. In fact, this one has to have a 2 in it, and it hasn't got a 1 in it. So I can see immediately it's not possible for this to be a 2, because a 2 would rule a 2 out of all of the cells in this cage. So this must be a 3, this must be a 2, and the 2 must be in one of those 2 positions. And the 2 must be part of the total, because there's no 1 in the 5 cell cage. So in this cage, we're going to have 20 something, and the other 3 cells will have to add up to 18. Which, well, I mean, I can't see why that's a problem. Well, no, indeed, it's not going to be a problem, but I can't see how to tell which way round these go. Okay, oh, we know we need to have a 30 total in that one. No, we don't know enough about 3s, I don't think. Okay, where are we meant to look now? This column, probably. We need to place 6, 7 and 8 into those squares. This square is open, can be anything. It's just the units digit of its total. We've got a 6 cell cage here. That's got a 2 and a 3 in it. Is that restricted? So, a 6 cell cage, if it's a 30 something number, then for it, I mean, just to show you what I'm thinking here, if this was 36, for example, we're looking at whether 4 cells can add up to 27. No, without using 9? No, they cannot, ever. Aha, right. This is important. Right, this is a 20-something, I think. Because if it's 30-something, the 4 cells that are not part of the total have to add up to 27. Without using 9, 8 plus 7 plus 6 plus 5 is only 26. Not enough. So this is... I'm presuming it can't be a tens number. Can it? No, it can't, because you can't make 4 digits add up to 9. So, this is the 4 digits that are not part of the total in this cage add up to 18. And they don't use a 1 or a 2. 2's part of the total. If this is like 26, the other 4 squares have to add up to 18 without using 1 and 2. So they have to be 3, 4, 5 and 6. Oh, this is absolutely extraordinary setting. It really, the reason this is extraordinary is this is just completely new, isn't it, this puzzle? I mean, I've not seen anything like this. It's just really, really clever. Now this cage now... Right, so we now know the 2 doesn't go here because the 2 has to be... It's a 20-something cage. And we know that the digits that are not part of the sum have to be 3, 4, 5 and 6. So the 3 must be kept away from the units digit of the 2. So this can't be a 3, I think. Because if that's a 3, you get a 2 above it. That would imply the total was 23, which is impossible. So that we know there's a 6 in the cage, so there's no 6 there. And we know there's a 4 in the cage. Do we know that we do? Yeah, here we go. We know that the 4 and the 6 can't be in this string of digits, because this string of digits includes a 2 and a 3. And the other digit it includes is the units digit of the 20 number, which must not be 4 or 6. So there is a 4, 5, 6 triple here. That is quite lovely. And maybe doesn't do anything. Oh, it gives me a 4, does it? There. Right. That's a 14 cage then. This square is 6, 7 or 8. It's not 6. These squares... I feel like I must know what these are. Maybe I don't. Six, 7, 8. Ah, right, okay, there's a simple deduction now in this cage. This can't be a 20 number. If we try and make this 20 whatever, let's make it 25. These 3 squares are going to have to add up to 18, and they don't. 6, 7 and 8 add to 21. So, just to remind you of the logic, obviously, if we've got 2 and 5 here, the 5 can just be removed. It's irrelevant to the total. So we need the other digits to add up to 20. Once we deduct the 2 from 20, we get 18. That's why we're always looking for multiples of 9. This doesn't add up. So this is wrong, or wroggen as we like to say. So this is 2. This is not 2. This is the total. We can colour it in. We shall make this time, we'll make it orange. These 3 squares are adding up to 18. So they're not. This is not a 7-8 pair. If this is a 7-8 pair, you have to put 3 here, and you can't. So this square is not 6, which means this square is 6. Using the column logic, we've got a 7-8 pair. So now, if this is 6 and 7, this would have to be a 5. Is there anything wrong with that? No, I can't see anything. If this is 6, 8, this needs... there we go. If this is 6, 8, it needs to be a 4, and it can't be. So this is 5. Which means this is 7. These are now adding up to 18. This is 8. And the box should work, and does. 2 is not here anymore. 7 isn't. This total for the red total is now 17. Now we know these 3 squares. These have got to be 2, 3 and 8. Now we know these 2 squares. They are a 6 and 7 to complete the column. Now we know those 3 squares. They are 1, 8 and 9. That's not 1. This total, of course, is 45. I should colour that in. 6, 7, 8. I've only got yellow left. Although I could use multicolours, couldn't I, today? Yeah, I might do that. So, yeah, I've got plenty of cages left. This is going to be an ideal opportunity. What do we do now? We've got Sudoku. That's what we should do in a Sudoku puzzle. 6 and 7 have to go into those squares. So these squares are now 3, 8 and 9. And these squares are 2 and 5. Now, do we know anything about any of this? This cage needs its other cells to add up to 9, doesn't it? So this can't be this domino can't be 1, 8, 2, 7 or 4, 5. It must be 3, 6. That gets us this square is a 7. This square is a 6. 3, 6 here. Yes, we can do that from the 6 we've just put in below. So this is 6, this is 3, that's not 3. Now we can ask where 6 goes in row 4, because this 6 rules it out of the same positions, or it can't go in its own cage, so the 6 must go there. So these 2 squares have got to be 3 and 8. These squares down here are 4, 7 and 9. 8, 8 ping-pongs back through the cage. There's definitely an 8 in this domino, so that can't be an 8, that must be a 9. 9 ping-pongs back through the cage and gets us a 4 or a 7 here. And 9 is now... Yes, 9 is now very... Oh, yeah. In fact, 9 is just placed, isn't it? In box 8. It's got to go here. So 9 is in one of those 3 positions in box 2. Do we know it's not there? Or could it be there still? No, because... Oh, right, yeah. These squares add up to 10, so this can be any digit it wants to be. So we don't know it's not here. We knew that the 7-cell cage is a 30 number, and we now know that the 3 goes in one of those squares. So what's that telling us? So it's saying it could be 38. So if it's 38, the other squares have got to add up to 27. Which means these squares have to add up to 12. So if this is 7, we couldn't use 2, 3 for the others. You'd have to have 1, 4 into those cells. And that is... I think it's possible, but only there. 1, 4 like that would work. If this is 4, you need these 2 to add up to 8. Without being 2, 6 or 3, 5. This would be 1, 7. The 1 would still go up here. This would be 7. So that's actually looking quite plausible. But if this is the 3, it all gets complicated, because 3... Oh, no, it doesn't get complicated. Forgive me. Right, sorry. No, look, if this is 3, doesn't matter what goes in this square. We can forget the units digits. These are just misleading. The point is this square becomes an 8. So now what squares have to add up to 27? It's this one, this one, this one, this one, and this one. Well, you can see those three already add up to 23. So these have to add up to 4. Forget this pencil mark. This pencil mark is only for if this was 38. But how would we make those two squares add up to 4? They'd have to be a 1-3 pair because we can't repeat a digit. But the 3 has already gone from the box. You can't make these a 1-3 pair. So this square can never be a 3. If it can't be a 3, it must go here. And this must be the 8. And this must be a 1. And this is 4 or 7, depending on what this is. And the 1 means this square is not 1. Which means this square is 1. Don't know if that gets us anything else. Maybe not. Oh yeah, 1 can't go here. So 1 goes in the corner. I don't have a song for that, I'm afraid. And now what do we do? I know the 38 is a colouring opportunity, so let us use that. Yellow, that's the last colour. We just need one more to go multicoloured now. Where do we find the opportunity to make more progress with the puzzle, though? We can... So I know this cage. Do I know anything about this cage? I know it's adding up to a... Yeah. Oh. Yes, I most certainly do. Sorry, I could have looked at this one ages ago. These two cells that are not part of the sum have to add up to 9. Well, that can't be 8 then. That's going to put a 1 underneath. That's a 3. That must be a 6. That must be an 8. Therefore, 3 is in one of those two cells. But this column is incredibly cluttered. It just needs 2, 3, and 4 into those squares. That's not 3 because of this 3. This one, not sure about that one. That one, the thing that interests me about that one is I can't put 1 in this 5-cell cage. And then we know it must have a 2 in it, and the 2 must be part of the total. So you can't put the 2 here, because if you do, you're going to have a very strange units digit in another cage. Oh goodness, that reminds me, there's another rule here. Consecutive cages cannot sum to 63. I've not used that at all. I've not even thought about it. Oh, is that why I feel I'm being slow? What's that saying? So this is the 45 cage. That cannot have 18 cages next to it. That's 17. That's 14. That's something else that's definitely not 18. This, that can't be an 8. Because that would be an 18 cage. But I wasn't actually thinking that would be an 8. So this square here is 5, 7, or 9. Okay. Oh dear. The other cage we've got that's big is the 38 cage. So that can't have a cage attaching to it, which is 25. Have we... That one could be... What's that? Oh, that's 28, of course. I just have to look at the colours to know what the total is, Simon. Don't be daft. 25. You could see if that was a 2, you could never put a 5 there anyway. I don't know. I'm not sure. I'm not actually sure I even understand why that rule is there. I don't think I had to use it up here. Anyway, let's carry on. I don't think that's what we need to do. We've got to do something else. And that thing is what? We know there's a 2 in this cage. Do we know where the 2 goes? No. No, we don't. Do we know... You see, this cage I've not put the colouring into yet. 2 can't go at the bottom. This is a 20 cage. 2 is in one of these. In fact, it's a 28 cage. We know it's a 28 cage. We just don't know if it's 28 here or 28 here. We know this square is definitely in the total. So we could try and make this colourful. Maybe I'll make it... Yeah, oh, I'm going to have to change the settings. One sec. Let's turn on multicolour mode. Go back. Now I can do that. There we go. Or maybe I make it purple and black, maybe, actually. That's quite snazzy, isn't it? Like, that's going to be a purple and black wherever the other one goes. Okay. We got anything going on? 6 can't go here. Oh, sorry about this. I'm completely stuck now. So if this was the tens digit of this cage, this would be a 24 cage. Cage. So this would, if this was a 24 cage, I'm just wondering if we can do some logic on the whole row. If this is a 24 cage, those 2 squares have got to, this would be a 3 and this would be a 1. So we'd have 28. That doesn't work. Let me just double check that. If this is 24, this is 3, this is 1. So this is 24. This is going to sum to 24. 24 and 4 is 28. These have to add up to 17, which means they need to be 8 and 9, and they can't be. Okay. That is a little bit of progress. This is not 2. This is 2. This is not 2. Threes, I've got pencil marked into the corners of those squares. Is that right? I've got 2, 3, 8 here and 3's in the corners for those 2. Why did I... Oh no, 3 can never go in the middle here. That's wrong. That pencil mark's wrong. I think I'd done it properly with my corner pencil marks, and then when I did the 2, 3, 8, I just 2, 3, 8'd it. But this square can't be a 3 because that would force this to be a 2 and this to be a 23 total, which it can't be. So 3's are now interesting, look. They've got to put a 3 in one of those cells. In fact, one of those 2 cells. Well, not that one. I don't want to put 3 in that one. One of these 2 squares. 3, 4. 3, 4 pair. That's got to be a 7. Therefore, this is a 4. And we're off and running again. Now we've got... I don't know why I said that, by the way. That was a very, very silly thing to say. 4 and 7 are doing what exactly? 7 is now in one of those 3 squares, along with 9. This column still needs 5, 7, 8, and 9. So this is just 7, 8, or 9, because of the 5 here. This one is just 5 or 8, because it can't be 7 and it can't be 9. So this box needs 2, 5 and 8. So 2 is definitely in one of those 2 cells. 2 doesn't quite align, look. But 2 is part of the total here in this box. Right. So this can never be 2. This can never be 2. Why not? If that's a 2, where do you put a 2 in row 9? The answer? Nowhere. You can't put it in the same cage. None of these cells seems to be able to be a 2, so you break the puzzle. So this is not 2. This square is 2. So now, what does that mean? That means we're either looking at a 23 or a 24 total, but more importantly, we don't care about that. Those 3 squares have got to add up to 18. So if this was an 8, these would add up to 10. Without being 1, 2, or 3, this would be a 4, 6 pair. Which... oh. Does that work? I'm not sure. It doesn't seem to immediately break. It might break if I investigated it a bit harder. Don't know. I'm not sure if that breaks or not. If this, on the other hand, if this is 5, these have to add up to 13 without being... they'd have to be 6, 7 then. Oh, actually, here you go. This tells you they're not 4, 6. There's a 7 in there. By Sudoku, there's a 7 in one of these squares. So scrap the ability for this to be 8. It can't be 8. This must be 5, 6, 7. There we go. These now do add up to 18. 6, 7 does what? It means this square is the only place a 6 can go. And this square is now an 8 because this is a 5. This 8 fixes the 3 here. Well, now we know the structure of this. This is a 28 and it must come down like this. So that means we can, yes, we can colour that one. This 3 is bouncing back into box 4 and giving us 3, 4, 4, 5. All of that's getting fixed. Now, these squares have got to be a 5, 8 pair. Not sure if that's doable or not. These squares are 2, 3, and 4. That one's not 3. That one's not 4. That one's... oh, done that already. 2, 3, 4. It's still resisting. I mean, it's incredibly clever that you can keep a puzzle like this hard to this point. So now... now I've got my 24 I can fill in. Look, so let's... how should we do that? Green looks like it's not being used. Green and red? That's very smart. Okay. It's another long video. It's a pretty difficult puzzle, this one, though. 8 here means this is not 8. So this is 5, 7, or 9. This is, we know that that's the total, don't we? Because this was a 20-something total. So those 2 squares need to be coloured in. We'll make those yellow and blue, I think. That's lovely. Now what do we do? We can... I keep looking down at these columns thinking that this is going to somehow resolve, but it doesn't seem to do that. 4, look, in this row has to be in one of those cells. Two is still possible. 2 is the total in this one, isn't it? Because it can't contain a 1. So this is... this is 20-something. It's got 3 cells in it that add to 18. This one's the same. These 3 squares have got to add up to 18, don't they? Maybe that's where we need to focus. Yeah, okay. These 2 squares are a 4-8 pair. So, okay, so if this is 8, this has to add up to 10. Without using 1s or 2s. So it's either 3, 7, which is going to be that way round, or it's 4, 6, which is going to be the other way round. So okay, if this is 4 on the other hand, these have to add up to 14, which would put an 8 or a 9 into this square. And oh no, actually you couldn't have 8, 9. Oh no, actually that would work. 8, 9, 6, 5. 5 is okay. That's been completely useless, hasn't it? Wow. Okay, sorry, that doesn't seem to crack the puzzle open. I've still got my 63. I bet that's what we need to find. Where is the 63 problem in this puzzle? Because I haven't found one yet, and there must be a point of this rule. So is it this? No, we already knew that square couldn't be an 8. It's something touching the 38. So 38 doesn't have a 25 next to it. So that's not a right, that's not a 5. Is that important? Okay, that becomes a 5. Why on earth is that crucial? So 5 is in one of these 2 positions in row 2. Oh, good, great. Yeah, okay. I see why it's important. Look, 5s are in one of those 2 positions in row 2, one of those 2 positions in row 6. So we ask the question, where does 5 go in column 2? It can't go in those, it can't go in those, can't go in those, it can only go here. So that means we get an 8, which is, what's that doing? Is that doing anything useful? Doesn't seem to be doing very much. It's pushing an 8 into this cage. Oh, okay, well that I'm not quite sure what that does yet, but it does rule out the possibility of having the 14 total in here, doesn't it? So I'm just going to get rid of these totals now and have a think about this again. In fact, can you ever put a 5 in here? No, you can't. That's the car. That's it. That's so clever. Right. We know there's an 8 in this triple here because of where the 8 can go in row 2. But we also know that these 3 squares together add to 18. So you can never have an 8 with a 5, or the other digit will be another 5. So this 5 is not possible. Which means that's a 5, I think. That's a 5, that's a 2. There's no 2 here anymore. There's no 2 here anymore. Oh, I don't believe it. I don't believe it. It's still not resolved this. I'm going to delete those squares and come back and think about exactly what they can be, given we know that there's an 8 in this triple. Oh, I'm so sorry if you're spotting what I'm missing here. Okay, so we know there's an 8 either here or here. So if this is 8, we know we're looking at either 4, 6, which looks possible, or 3, 7. Which also looks possible to me. Whereas if this is 4, I know there'll be an 8 here, and then I'll need a 6, won't I? Which will be here. So that's the same. 4, 6. Well, I have to put the 8 possibility in. So this, I think, is the complete panoply that we've got for row 2 of the grid. Sure, there's something I'm... yeah, okay. Where does 9 go? That's a sensible question. 9 can only go there. So that gives us a 7. Still doesn't crack. That still does not break the puzzle. It just gives me one digit. One useless digit. Because remember, the units digit doesn't affect the total of those cells. $29. Yeah, I can see this is ambiguous. Okay, what do we need in row 3 then? We need 4, 8, and 9 into those squares. And we can rule out 8 from one of them. And nothing from this. What am I doing wrong? Oh, I'm so sorry about this. I've got this cage left to figure out. Is there a way we can figure out this cage? If this is a 2, those 3 squares have to add up to 18. So they couldn't be 5, 8. They couldn't be 4, 9 either. Oh, that's beautiful. Good grief. Good grief. This cannot be a 2. Because if it's a 2, these 3 have to add up to 18. This domino has to add up to 13. It can't be 5, 8. There's a 5 there. It can't be 4, 9. That would break that square. And it can't be 6, 7 because that square would be broken. So this is not 2. The 2 is here. And hopefully that doesn't. Why does that going to work? Oh, I see. That's going to allow. Is you've still got a similar problem, but I can see how it's fixed now. So let's put some colours in for these. We can put in orange maybe. And grey. Oh, that's not too bad. Okay. The key thing now is these 2 squares have to add up to 13 without breaking the puzzle. Well, again, so we know this isn't 8. This is going to be 4. We knew these couldn't be 6, 7. That will break that one. But 4, 9 is now possible with the 9 here. And that doesn't break this square. So there we go. I think we're now on the home stretch. Because now we can say that's an 8. This 4 is giving us the 4 and the 3. We now know this is 8 and this is 9. We now know that this is 7. Therefore, that's 7 and that's 6. That's 3 and that's 6. That all looks like it's working. The 9 and the 7 could flow down the grid now. The 3 and the 4, the 7 and the 6. And that should be a 2. And there we have it. What a beautiful puzzle that is. I'm just going to click check. Yes. Oh, wow. That is incredibly clever. Quinlux again with one of these build your own puzzles. That is just stellar. It's another hour-long video. I'm so sorry about that. I just wasn't clever enough to do it more quickly. But I did really enjoy it. And I hope that that's some recompense. And goodness me. I mean, the fact that that is solvable. Hey, why do you have the idea that that could even be made solvable? And you think about the work the compiler's done. The compiler would obviously have had to think about, look, 3-cell cages, they must have 1s and 9s in them if I use this rule set. And then to figure out that 5-cell cages must contain a 2, and then how to build that into the solve path so that it flowed like that. It's just genius, isn't it? It really is. Absolutely loved it. Thank you so much for watching, and we'll be back later with another edition of Cracking the Cryptic.